Okay, the third method to solve a linear system is called elimination. So we know how to graph two lines and find a point of intersection. We know how to do it algebraically using substitution, and now you're going to learn another algebraic method called elimination. Okay, if you just know substitution, you can always get the answer, but it just might take a lot of time. And usually a lot of people like elimination because it is lightning fast in certain instances, right? Not always. But when you see that that instance is available, you're allowed to move at lightning speeds. So you have to look for that thing. So solving a linear system by substitution means we have to add or subtract to eliminate a variable. If I have two equations, if by adding or subtracting it eliminates a variable, I'm allowed to do that. I can add two equations. Okay, so I probably have no idea what that means, but I'm going to take a look at this question. I have to solve this linear system by elimination. If I add these equations or subtract these equations, look what I'm going to get. I'm going to subtract first. 3 minus 4 is negative 1x. Y minus negative y is 2y. I'm going to say that again. Y minus negative y is 2y. 19 minus 2 is 17. I have an x, I have a y. Nothing was eliminated by subtracting. Let's try to add. 3x and 4x is 7x. Y plus negative y, 0. I've just eliminated the y's. And this is a 21. So I have to choose either addition or subtraction. Whatever operation leads to an elimination of a variable. It's really easy. If you have letters that have the same coefficient, if the signs are different, like if you have two things that are different signs, you eliminate them by adding, right? Whereas if they have the same sign, 5 and 5, you have to subtract them to eliminate. So if the signs are the same, you subtract. If the signs are different, you add. So I go equation 1 and equation 2 here. I maintain my notation. And I know that if I add these two equations, equation 1 plus 2, I'm going to eliminate. So I'm going to do 3 plus 4 is 7x. Y plus negative y is 0, and this is 21. And right away, I can go x equals 3, right? From the 7x equals 21. Okay, so all I did was add these equations. Okay, you might have thought, well, it's easy to substitute. I can solve both of these for y, or at least one of them, plug it back in. Yeah, it's probably going to create more work if you use substitution. Okay, so we like elimination when we have all our variables on one side and our number on the other. That's how we like it. Okay, if it doesn't look like that, make it look like that. I'm going to take this, choose an equation, and plug it back in. I'm going to choose the first equation because it's a positive y. So I'm going to say from equation 1. And I'm going to substitute that x value into x. I'm going to do 9 and subtract 9 at the same time. And y is 10. I'm going to box it. I'm going to read the question, solve the linear system. Therefore, solution is 310. Done. Easy. Okay, we love elimination because it is less work sometimes. Obviously, this is a 0 out of 10 difficulty for elimination. Next level up is, well, what if we can't eliminate something? There's nothing I can do to a 10 and an 8 to eliminate it if we're talking about addition and subtraction. There's nothing I can do to a 4 and a negative 2 by eliminating by addition or subtraction. So if I add or subtract, nothing will eliminate. So I have to force something to look the same. Hard to force these guys to look the same. Very easy to make this 2 into a 4, if you can see that. So I have to make one of the coefficients the same as the other one from the other equation. This is a really easy one. If I call this equation 1 and equation 2, I'm going to create from 1.3 an equivalent expression for equation 2. And it's going to be equation 2 times 2, which is going to be 16x minus 4y equals 14. And this is going to be equation 3. Now, my advice is when you do this, I like to very lightly just cross out the equation I just changed because I never want to look at that equation again because I changed it for a reason. And having 3 equations there, sometimes I'm going to get confused. Now I have my equation 1, my equation 2. I can eliminate the y's because they're both 4s. The signs are different, so I'm going to add. If I eliminate, I can add, or vice versa. 10x and 16x is 26x. I can draw a line here to separate it if you want. It's just visual stuff. 4 plus negative 4 is 0. See how I'm doing the addition or subtraction in my head, you shouldn't even have to do that. If you're choosing the correct operation on two coefficients that are the same, it's going to eliminate. So stop doing the math. It's going to be 0. Whatever number is the same, it's 0. Just do the first one, do the last one. Okay? There's chances that you might make a mistake with your subtraction or addition. -1 plus 14, 13. X equals 2. Okay? One setup spot to get to max easy. Now I'm going to go from any one of these equations. The only equation, yes sir.
Isn't that 1 over 2?
Sure is. Thank you, sir. Now I'm going to show work because of that mistake. Now I'm going to pick an equation. Okay. The only one I'm for sure not going to pick is equation 3 because those numbers are just bigger than another equation. Okay, so I can pick the first equation or I can pick the second equation. I'm going to pick the second equation just to change it up. So from equation 2, I'm going to say 8x minus 2y is 7. This is a 4. The 7 is moving this way and the 2y is moving that way. Take a look at those two steps in one there. I'm doing a double switch. This becomes a -3 is 2y, so -3 over 2 is y. Solve the linear system, therefore solution is in brackets 1 over 2 and -3 over 2 fractions. I want to talk about what equation to choose, just so you know, so we can move faster. If I'm plugging in a fraction like a half into one of the equations, it doesn't really matter here because that's a 10x, that's an 8x, that's a 16x. But if one of them was odd, I would not choose that one. Like if that was like a 9x and a bunch of 1s, I'm still probably not going to plug it into there because I'm going to get a fraction as a result. So because this is a half, I would love to plug it into an x value with an even number in front to eliminate the fraction. And just think a step ahead. Done. Okay, we only have to do one thing here to fix up. No problem. Last one, higher difficulty. Now we have to do two things to change the coefficients that look to be the same. For instance, I can't get to a 4 to get to a 5. I can't get a 5 to get to a 4. But I can get both to be a 20 very easily. I can't get a 3 to look like a 4 or a 4 to look like a 3. I mean, technically I can, but it's too complicated. But I can get both of these to be a 12, right? So I can choose what I want to eliminate. I'm going to choose the x's just because I want to subtract this time. So if I call this equation 1 and equation 2, I'm going to do equation 1 times 5 and equation 2 times 4. Okay? Doing this will result in both x's having the same coefficient. So equation 1 times 5 is 20x plus 15y equals 65. And the next equation times 4 is 20x minus 16y equals -28. This is now equation 3 and 4. And now you can see I'm ready to eliminate. Okay, and if you're thinking, oh, maybe substitution would be easier in this question, probably not, because you have to solve for a variable that has a coefficient, so you're definitely in fractions, you're substituting in fractions, disaster. Okay, so have faith and eliminate. My x's are the same. To eliminate them, do I add or subtract? Definitely subtract because the signs are the same. For a 20x and a 20x to disappear, I have to subtract them. So I'm going to say equation 3 minus 4. Don't even do it. 0. This minus this. If you're not thinking 31, you don't know how to subtract. Okay? Never think subtract a negative. As soon as your brain thinks subtract negative, just go back and say plus. 15 minus negative. No, 15 plus 16. Don't say minus negative for the rest of your life. Minus negative, go back half a second and change it to plus everything. 65 minus add. 93. Y is 93 over 31. Y is 3. Done. Okay? Minus negative. Terrible. Too many words for possible mistakes. I'm going to pick any equation to substitute this back in. Definitely not picking 3 or 4. Let's go with the first one. It's a nice positive y value. Oh no, I already have y. Let's go with the first one anyways. Sure. From 1. Okay, so again, I can pick any of these four equations to substitute it in. Just pick the one you want. 4x plus 3 times 3 is 13. So I'm replacing the y value from the first equation with the y value that I solved for. And now I can solve this. This is a 9. That's a 13 minus 9 is a 4, so x is 1. I have x, I have y, I read the question. It's not phrased in the same way as the other two, so I'm going to change this therefore statement. Therefore, the point of intersection is 1, 3. Done. Okay, it does get harder than this. I'll show you some more difficult ones after the video. But remember, equivalence expressions is so important because I can change equations into whatever I want. Okay, and if it makes sense to make them both 20s, then go 20s. If it makes sense to go both 12s, go 12s. If I have a bunch of decimals and I don't want to rock with decimals, just multiply by like multiples of 10s. Now I'm going to multiply everything by 100, get rid of my decimals. You have a bunch of fractions and you have to do elimination. Oh, so this is too difficult. Just multiply through by the common denominator and your fractions are gone. Okay, so there's always a good decision to make early to make it easy.